All right, hello guys, welcome back to class. And now we're going to continuing making an Astable, that is a square wave oscillator from our 555 timer. Before we do that, let's look at the schematic. What does the schematic look like if you want to make something in that order? So look at this. This is an Astable. This is a circuit diagram for an Astable, and we are going to be repeating the same thing. So the expected output is like this. It's going to look like this pulsating waveform. This is what we expect to see at the output voltage. And that is what we mean by an Astable multivibrator. All right, let's see this circuit. Let's start. Pin 1 is connected to ground. So let's go to our simulation software and bring our 555, the 555 timer first. Rotate it. We need our power supply. I love using this now. And pin 1 goes to ground. There goes pin 1. Pin 2, let's check our schematic again. Pin 2 and pin 6 are connected together. Then it goes to a capacitor to ground. 2 and 6 are connected together. This is pin 2 and this is pin 6 over here. And it goes to a capacitor to ground. Let's change it to a green wire. Then we need a capacitor. And this capacitor goes to ground. Let's just connect it all the way to the negative here. And change the color to black. That's connected. Then the next connection is that the same goes to a resistor to pin 7, right? So let's do that connection. That is from this junction between pin 2 and 6, it goes to a resistor to pin 7. Let's bring in a resistor. Let's just place the resistor around there and connect it. Pin 7. Okay, that is connected. Then from this junction of pin 7 goes for another resistor to the power supply. Let's do that. Another resistor here. Then goes to the power. So let me bring a positive power line from here. And let's change the color to red. Okay, that side is done. To the next connection. Then we have pin 4 here. Pin 4 and pin 8 are connected together. Just like when we were building the circuit for the Astable. Pin 4 and pin 8 are connected together and then it went to the positive power supply. So I'm just going to connect to the positive. Then connect this one to pin 8. Okay, that's been done. What else? We have not connected pin 3 and pin 5. Let's see. How is pin 3? The pin 3 is the output and it's connected via a load resistor. And then pin 5 is left floating. I think that's all of the connection. So we're going to connect our pin 3 to a light emitting diode. We're going to connect our pin 3 to a light emitting diode as the load. Okay, so I need a resistor for that. Okay, we can connect it like this too. Change to green. And connect the light emitting diode. To ground and change to black. Okay, so with this, we've completed the circuits for an Astable. But before we go ahead and simulate this, what are the values of resistance? What are the components that determine the frequency of oscillation? So from the data sheets, the values that determine the frequency of oscillation are this resistor, RA, RB, and C. And it is given by this formula here. So the frequency is given by 1.44 all divided by RA plus 2RB multiplied by the value of C, right? So let's just, so that means that if we simulate this circuit like this, it's still going to give oscillation, but it's not going to be visible because these values are low and the frequency to generate will be somehow high. So let's do this. Let's leave this as 1K, but let's change this to like 47 kilo ohms, and let this be like 10 microfarad. So given the values of this resistor, what will be the frequency of oscillation? Let's go ahead and do some calculation. So in our calculation, remember that the frequency is given by 1.44 all over R1 plus 2 of R2 multiplied by C. Now my R1 is 1K from the schematic. My R2 is 47K. And my R3 is 10 microfarad. Okay, so let's put this into the calculation and see what we have. 1.44 all over R1, which is 1K, that's 1000, plus 2 times, let's put a bracket here, 2 times 47,000, double brackets, multiplied by the value of C. That's 10 times 10 to the minus 6. So that will give us, let's first punch the calculator. So let's do 2 times 47,000. It's 94,000 plus 1,000, 95,000 multiplied by 10 microfarad. 10 microfarad. That will give me 0.95. So it's 1.44. All of the denominator is equal to 0.95. Okay, so when you do this division, you are going to have 1.44 divided by 0.95. That's 1.5 hertz. 1.5 hertz. So that's the frequency of oscillation that you obtain using these values, 1.5 hertz. Now, what does 1.5 hertz means? It means that it's blinking at 1.5 times per second. That is, if it were to be 2 hertz, it will be blinking 2 times in 1 second. If it were to be 1 hertz, it will be blinking once every second. So 1.5 is between 1 and 2. So that means the duration of blinking is a little bit higher than 1 second. So let's see if that is correct by our simulation. So let's start simulating the simulation now. So you see the LED is blinking on and off. It's not that bright because the value of this resistor is 1K. Let's change it to 220 ohms. So you see, now you have a blinking light emitting diode in this manner. So this is a simple astable multivibrator. By changing the values of R1, R2, and C, you can achieve different frequency. Now I'm going to have you do this because part of the project, the final project is to build a simple inverter. And we're going to be using this Astable in the final project to build this simple inverter. So this is your assignment. The assignment is to create an Astable multivibrator that oscillates at 50 hertz. So your frequency is 50 hertz. That means you have to find the value of resistor, this resistor, and this capacitor that will give you 50 hertz. All right, have you learned that? Okay, let's continue to building a bistable multivibrator. So I'm going to do the two side by side. Let's do the two side by side. So go back to your, if we go back to our data sheet, let's see missing pulse detector, pulse wide modulation, sequential timer. Okay, there's no notes for a bistable here. All right, we just go ahead and create it. We just go ahead and create it. Now for a bistable, we still need our 555. Let's do something unique. I'm going to remove all of this. So let's bring in our 555 here. So we want to make a bistable around there. So in a bistable, these are the following things you need. Your pin 1 still goes to ground. Don't forget. Your pin 8 goes to the power supply. Right? Your pin 3 is still your output. So I'm just going to copy what we have here. And this still goes to ground. Right? Your pin 4 is your reset. So we're going to leave it for now. So pin 2 is what you use as trigger when we were building our monostable. We are still going to use same pin 2 as trigger again. So for that, we need a button switch. We need a button switch. And I need a resistor. I'm just going to copy this, Ctrl C, Ctrl V, and it goes to pin 2. Color red. Color green. And this goes to ground. So that's pin 2. Now, pin 4 is the reset. Pin 6 is the threshold. So we're going to connect. Let's simulate this. Pin 7, we don't need pin 7. So pin 5, we don't need pin 5. I'm going to copy all of these and paste. Okay, let's put it here. So the circuit will not be clumsy. So I'm going to connect this to pin 4. This goes to ground. And this to pin 4. Now don't be confused by here. In a button switch that has this configuration, internally this side and this side are connected together internally. So this connection is more like connecting to this junction 2. It's the same thing. All right, let's simulate this circuit to see how it operates. So presently the light is on. If I press this button, the light is off. You see that if I press this button, the light comes on. That is a bistable. That is, the light, depending on these two signals, the light can be turned on and turned off. If the reset pin is shorted to ground, that is, there's no voltage on the reset pin, the 555 timer's output will be off. So that means that we can use the pin 4, that is the reset pin of 555 timer, to also control the 555 timer. And that is what we are going to do next. So this is what we want to do. These two circuits, this is an astable, this is a bistable. We want to use the output of this bistable to control this astable, such that it is when we press this button that this light should start blinking, the oscillation should start. And when we press this button, the oscillation should stop. Do you get that? Okay, so let's do that now. I'm just going to take the output from here. We delete this. And I will connect it to ground via a resistor. 10k resistor will be fine. The 10k resistor. To ground. Then this one goes to the reset. Why am I doing that, connecting to ground? It's simply because it's so that this pin 4 will always be in reset mode. It's grounded normally. So I will take output and output from here and feed it back to pin 4 here. And this should go to ground. Don't forget that. Or else the light will not come on. I just take it all the way to that point. Okay, now we've made the connection. Oh, pin 1 here is disconnected too. Sorry about that. Thank God I saw that. Okay, what's next? Let's see. So don't forget, this side is an astable, this side is a bistable. So let's run this simulation. As long as this light is on, this also will be blinking. Let's see. You see now. You see that. You see that. Okay, the next thing now, what if we reset it? You see, this has stopped working. So we are using the output of this bistable to control this other astable. So let's start it again. You see that now. So this is simple control circuits. Off. So this is like an a on button, and this is like a off button. All right, that's beautiful. That's beautiful. You may think that why do we need this kind of button when you can just put a heavy button on the power supply? Have you seen an inverter before? Do you realize that all inverters, most inverters are controlled by just that small button switch? So that means they are not controlling the switch, the power to the inverter from the power line. They are using signals like this to control it. So when we are building an inverter, we can use something like this too to control it so that such that this thing will not oscillate except I press the power button. That's when it will start oscillating. All right, have you learned it? Another assignment I would like to give you is to make the frequency of this adjustable by putting a potentiometer in series with this resistor. Put a potentiometer in series with this resistor here. So we have that as an assignment. That will be all in this session. I believe you've learned something about 555 timer as a monostable, as a bistable, and as an astable. You are free to go online, check online to see different uses, different things that people have used the 555 IC for, and you are free to also practicalize the same. The 555 IC is actually very versatile. It's a very versatile IC, and you can do a lot with it. I remember sometimes I built a battery charging solution with 555 IC. So what I did was that when the battery is low, it will trigger this one. So this one was not a button. It was like a sensor, a part that measures the battery voltage. And when it is low, it triggers this one. And when the battery is full, another sensor measuring the battery voltage triggers the reset. So your battery don't overcharge. When it is low, it starts charging. When it is full, it stops charging. You see that? So depending on the imagination of your mind, that's what the limit of what you can bring to being using these ICs. All right, bye.